The next rules for differentiation which we're going to look at are going to involve our 6 trigonometric functions. So let's start off with the first one, which is y equals the sine of x. We're interested in finding its derivative. We don't really have much of a place to go, other than we know the definition of the derivative. By definition, f prime of x will be the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. Now this in itself can actually be simplified, but we have to remember our identities for a sum or difference involving sine, which may not be at the tip of our tongues, and we have to do some other special limits as well. But this actually can be found out, and you can find this on the internet. I'd like to get the derivative of this using pictures, in other words, using our graph. So let's examine the graph of this expression right here, this limit. The calculator is not going to divide by 0, so we're going to have to work around that. We're going to have to make h really, really close to 0. So let's flip over to the calculator and take a look at what we can see. Here we have the TI-84 calculator. We're going to take a look at the graph of the derivative of sine. For starters, let's graph sine. So if we go to y equals, see that we have sine x ready to go. We also have the derivative of sine, but it's not activated yet because the equal sign is not highlighted. So this is going to graph sine. So I'm going to zoom in, and let's do zoom trig. All right, and that's just because, whoops, too far. Sine is a nice trigonometric function. So we hit enter, and here comes the graph of sine, which should look familiar from pre-calculus. Now we're interested in the graph of its derivative. We know that sine is a wave function. Let's take a look at what's going on. So in y equals, I'm now going to turn off the sine function, and I'm going to turn on the derivative of sine. Now there's the limit of the difference quotient. By hitting enter on the equal sign, I turn it on. We see sine of x plus h minus sine of x all over h. Now remember, we want to take the limit of this as h approaches 0. Now we have to mimic the idea of a limit. We just have to make h very small, very close to 0. So I'm going to quickly go back to the main screen, and I'm going to store 1/10,000th into h. So store it into the h variable. So now h is really close to 0, but not actually equal to 0. So when I go for my derivative, again, let me go back to y equals, we're going to be working with h's that are extremely close to 0. Let's take a look at the graph of sine's derivative. We can see that we have a wave function again. So our derivative looks like it's similar to sine. But how well do we know our trig graphs? Is this sine? Let's go back for a second to y equals, and let's turn on the sine function. Are they one and the same? Well, here comes the sine function. We can see that it's not quite the same. It's been shifted over. It's been shifted over pi over 2 units to the left. So the derivative of sine, which is the black curve, is not quite the same as sine itself, which is the blue curve, but they are similar. What trig function had a very similar graph to sine? Yeah, cosine. Let's go back to y equals. I'm going to delete the sine function, and I'm going to put cosine in instead. Watch what happens now as we graph cosine in blue and the derivative of sine in black. Here's our cosine function, and here's the derivative of sine. It's covering it up exactly, because it can actually be proven, if you work with the limit of the difference quotient and you do all your trig identities, that the derivative of the sine function is in fact the cosine function. So we now know that the derivative of the sine of x is equal to the cosine of x. All right, that is our newest rule, the sine rule. The derivative of sine of x is equal to the cosine of x. What about cosine? What is its derivative? Let's go back to the graphing calculator and see if we can figure out what's going on with the derivative of cosine x. If sine derives to cosine, does that mean that cosine is going to derive to sine? Let's find out. So we're back here. We now have the cosine function in as y1, and the derivative of cosine is temporarily entered into y3, but I'm not going to graph it yet. I just want to look at the graph of cosine. So if I do zoom trig, here's the graph of our cosine function that we just saw. We see that the hill of the function is split by the y-axis. Now we're interested in looking at the derivative of cosine. So I'm going to go back to y equals. I'm going to turn cosine off for a second. And I'm going to turn cosine's derivative on. Here comes the derivative of the cosine of x. We were wondering a moment ago if the derivative of cosine is sine. Well, it does not quite seem to be the exact same as sine, although we do have the hills and the valleys. Let's put the sine of x on there and see how the two graphs match up. So I'm going to go down to y2, and I'm going to put in the sine of x. And take a look at the graph. Here's the sine of x. Okay, so we see that the sine of x is basically the reflection. If we reflect it over the x-axis, then we have the derivative of cosine. So cosine's derivative is not sine because the black and the red graphs don't match up. If we were to make a match up, we have to reflect over the x-axis. How, graphically, do you reflect something over the x-axis? Well, if you said that you negate it, you would be correct. So we're going to clear this away. Let's put in the opposite of the sine of x. So now we're going to have the opposite of sine x come into play in red. And then we're going to have cosine's derivative come into the graph in black. And we can see that the two graphs match up, just like they did for sine's derivative. So what this means is that the derivative of cosine, which is in black, is equal to the opposite of sine, which was the graph in red and still is. It's just been covered up because the two graphs are one and the same. So going back here, y2, your opposite of sine x, that is your derivative of cosine. Bringing everything to a conclusion, we already know that the derivative of sine of x is cosine of x, and we now know that the derivative of cosine x is the opposite of the sine of x. So these are our sine rule and our cosine rule. Two derivatives that you definitely want to know. These are going to come up throughout the rest of the examples in this section. They're going to come up on the AP exam. And in addition to that, we're going to use the derivatives of sine and cosine to find the derivatives of the other four trig functions. So pause from the lessons and watch a couple videos involving the examples below.